Hey everyone, welcome back to the channel. Today, we are diving into week 1 of CS50x. This is where we begin our journey into the world of programming using the C language. This week was all about learning the basics: how to write code, how to compile it, how to run it, how computers think, and some foundational concepts that every developer should understand. CS50 provides a super convenient coding environment called the CS50 IDE. It is like a mini operating system inside your web browser. It includes a graphical user interface, also called GUI or the GUI, with a sidebar to manage your files, and a built-in command line interface, also called CLI, where you can do almost everything you can with the GUI, but faster. And like a pro, we learned some essential terminal commands like cd, change directory, ls, list files, cp, copy files, mv, move or rename files, rm, remove files, add -r to delete directories, recursively add -f to force deletion, pwd, print working directory. We created a file called hello.c and wrote our first C program. Then we used make hello to compile the program, /hello to run the executable. We also learned about header files, for example, include standard input output.h2, gives us access to functions like print, include CS50.h, a custom header provided by the CS50 course. It includes helpful functions like get_string and more. Every C program needs a main function. This is the starting point of execution. It looks like this. C is a statically typed language. This means we must specify the type of data we are working with. Here is a quick rundown. Bool, true or false. Int, integer, from -2 billion to +2 billion. Unsigned int, integers from 0 to around 4 billion. Float, decimal number, using 32 bits. Double, more precise decimal, using 64 bits. Char, a single character. Void means no value or nothing. In C, you must declare a variable's type before using it. Declaration, int number semicolon. Assignment, initialization. To get user input, get_int. Format specifiers in printf include %i for integers, %f for floats, %s for strings, %c for characters, and so on. Loops help us repeat actions. C offers several types of loops: while loop, do while loop, and for loop. Example, using do while loop, enter a positive number, while number is less than 1. If you ever get stuck in an infinite loop, just press Ctrl+C in the terminal to exit. We also learned about relational and logical operators: not equal, greater than or equal to, less than or equal to. Logical operators: double ampersand for and, double vertical bar for or, exclamation mark for not. With that being said, let's look at the problems this can cause. Integer overflow. An integer can only store values up to approximately 2 billion. If a calculation exceeds this limit, it causes an overflow. The value then wraps around, leading to incorrect results. Real-world example: Boeing once faced a critical issue. Their generator control units were programmed with a 32-bit counter. It counted time in hundredths of a second. After 248 days, or 2 to the power of 32 hundredths of a second, the counter would overflow. This could cause the system to fail. The solution they found is to reboot the system every 230 days. Floating point imprecision in binary: we represent decimals by multiplying the fraction by 2 and taking the whole number part step by step. Example. The problem is we are limited by the number of bits. Some decimal numbers are not finite in binary. Example, 10 divided by 3 in decimal is 333. In binary, it repeats. Step 1. 0.3 times 2 equals 0.6. Take 0. Step 2. 0.6 times 2 equals 130. Take 1. Step 3. 0.3 times 2 equals 0.6. Take 0. Step 4. 0.6 times 2 equals 130, take 1, and so on. The solution? Use standards like IEEE 754 that define how to round or truncate these numbers to fit into bits. So 10 divided by 3 equals this, and 0.1 plus 0.2 does not equal 0.3 because it equals this. Just like the Y2K bug, computers that store time as the number of seconds since January 1st, 1970 using a 32-bit signed integer will overflow in the year 2038. It may affect systems that rely on time calculations, especially embedded systems. Now let's talk about the week 1 problem set, called credit. The task? Write a program in C that checks if a credit card number is valid. Here's how it works. Credit card numbers follow specific patterns. For example, American Express starts with 3437 and has 15 digits. MasterCard starts with numbers from 51 till 55 and has 16 digits. Visa starts with 4 and has either 13 or 16 digits. But most importantly, the number must pass Loon's algorithm. This is a checksum formula that works like this. Starting from the second to last digit, multiply every other digit by 2. If the result is 2 digits, add those digits together. Then, add that total to the sum of the digits you didn't multiply. If the total ends in 0, the card is valid. Sounds like a lot? Let's break down my solution. In my code, I use a loop to go through each digit, from right to left. I apply Loon's algorithm step by step and calculate the checksum. If the checksum is valid, I check the starting digits and length to determine the card type. If it matches a known pattern, I print Amex, MasterCard, or Visa. Otherwise, I print invalid. This project taught me a lot about loops, math logic, and real-world validation. Using only the C language, Week 1 of CS50x gave us an amazing introduction to programming in C, from writing our first lines of code to understanding how computers process data. It is a deep but very rewarding journey. If you found this video helpful, make sure to like, subscribe, and share it with anyone who is starting CS50x. And in the next video, we will tackle Week 2, where things get even more interesting with algorithms and memory.